Okay, here's number one on section 15.2. In section 15.2, we're looking at a test for randomness called the runs test. Kind of sounds bad, but it just means we're going to assume that this string right here of like male and female, it could be anything, could be a string of numbers or whatever. But we're going to assume that it's random. That's be the null hypothesis. And then the alternative hypothesis is that it's not random. Okay. So the way that we do this, the first thing that we do is we just see how many elements there are in the string. And this student has gotten 14, right? If you count up all these things, there's 14. And then how many of each different type of element there are. And it's not that really important which one's N1 and N2, right? I'm taking it that N1 here for this student was 1, 2, 3, 4, 5, 6, 7, 8. Yeah, is the number of M's or males, and 6 is the number of females here. Now R is the kind of tricky one to get. That's just how many different runs there are of the same kind of thing. So here we have one run of a male, and then two runs. The second run is just a female run. The third run's a male run. The fourth is two females. The fifth is two males. The sixth is a female. The seventh is three males. The eighth is two females. And the ninth is a male. So you count the first one, and then you count every time you flip over to the other element, whatever the other element is in the run. And so we have 9 for our R. That's the number of flips. Okay. Now, what we have to do at this point is go to the table and get critical values, which are going to be 3 and 12, but I'll show you how to get that. So if you open up the textbook, it's in the very back in the table section. It's A24 that's appendix 24. It's got the table number 11 in Roman numerals. Okay. And if you're doing it on the ebook online, you can just hit A24 and the page number here, and it'll bring you here. Okay. And then we just need what are our N1 and N2 values, 8 and 6. And so our N1 value is 8, right? That's in the row. The columns are the N2 value, that's 6. So where these two meet is 3 and 12. So 3 gives us the lower critical value. 2 gives us the upper critical value. Okay. So now if our R is below 3 or above 12, we're going to reject the null hypothesis that the string of letters is not random. Okay. And of course we don't here because our R is 9, right? It's between 3 and 12. So we do not reject that the sequence is random since the test statistic is between the critical values. The other thing I forgot to mention is that there are 2 versions of the test depending on how many elements there are in the string. And here we're doing the small case, trying to remember. Yeah. So if you got more than really, if you have more than 20 elements of each type, that's when you do the large case. Okay, but this is just a small case because there's not even more than 20 of a single element, of both elements. So I hope that helps on this problem. This is just really a test to see if something's random or not.